Hello friends, you are most welcome to our ongoing Six Sigma journey, and I hope you are enjoying the learning of various topics. I can understand that we have gone through many lectures and discussed variety of the topics, so you need to keep revising them frequently so that you can digest it properly, remember them, and also you can apply. Now we are in the lecture 47. Last lecture we talked about Taguchi concept illustrative application. Today this particular lecture is about 7 QC tools, quality control tools. Now let us begin with a beautiful inspiration. If you don't know how to ask the right question, you discover nothing. And this is what is said by none other than the great quality guru W. Edward Deming. I will just share a small example. Many times at IIT, students they come to me and then they will say, sir, then they will stop. They will just then utter some other word, sentence, and then they will stop. Now they would expect that without understanding what is their question, I would be able to help them. That never happens. So I never open my mouth unless they put their question, define their question properly, and once it is done, I think almost 70% of the problem is solved. So if you don't know how to ask the question, you are just say beating around the bush, then you do not achieve anything, you discover nothing. It's a very important and great insight, and that is why we are going through the various phases of DMAIC. Now we have gone through huge amount of quantum knowledge in this particular course so far, and it's a time to have a quick recap what we have studied so far and where are we in our Six Sigma journey. So let us see. We had devoted week 1 and 2 on discussing quality fundamentals and key concepts. So in that week 1, we have talked about the overview of the course, quality concepts, definitions, history of continuous improvement, various phases, and Six Sigma principles and focus areas, part 1, part 2, Six Sigma application. Week 2, we talked about basically quality management, TQM, cost of quality, voice of customer, quality function deployment, management and planning tools, and this we have discussed in detail management and planning tools in part 1 and part 2. Then we started with the DMAIC cycle, and the first phase was the define. We talked about define phase in week 3, and as a part of that we have seen the project identification, definition, selection, project charter and monitoring, process characteristic and analysis, process mapping using a very important tool SIPOC. Then we entered into the measure phase week 4 and 5, and this week 4 basically we talked about data collection. We divided it into 2 parts: measurement system fundamental, measurement system gauge R&R study, fundamentals of statistics, probability theory, and in week 5 we talked about process capability analysis, indices, process capability analysis in Minitab, and non-normal process capability also with application in Minitab. Then we entered into the analyze phase. So DMA, we are going in a very structured manner so that lifelong you will not have any difficulty in understanding the concepts of Six Sigma and applying this concept for the selected problem. So analyze phase was covered in week 6 and week 7, and week 6 basically we talked about analysis through hypothesis testing for one population, for two population, and we had also seen for the convenience how this can be done in Minitab, correlation and regression analysis, and model validation of the regression analysis. Week 7 we continued in the analyze phase and we talked about one-way ANOVA, two-way ANOVA, multivariate analysis and failure mode effect analysis. Then we entered into the improve phase and week 8 and week 9 were devoted. So week 8 basically talked about introduction to DOE, randomized block design, Minitab application, factorial design with Minitab application. Week 9 we focused on fractional factorial in Minitab, Taguchi method and the illustrative example of the Taguchi method which we covered in the last lecture. So you can see that we have covered a huge amount of quantum in our systematic journey of DMAIC, and now you will have a little feel of relaxation that we are now in the final phase of our DMAIC cycle, that is the control phase. So week 10 and week 11 is devoted towards the control phase of my DMAIC cycle, and as a part of this I would like to discuss lecture 47, that is this lecture, 7 QC tool, 48 statistical process control key concepts, statistical process control for variables, then operating characteristic curve for variable control charts, statistical process control for attributes, then statistical operating characteristic curve for the attributes. Very systematically the plan is drawn so that you don't have any confusion, and then the application of statistical process control in Minitab. Week 11 lecture 54 is about acceptance sampling key concepts, 55 design of acceptance sampling for attributes. It's a long topic, so it is divided into part 1 and part 2, lecture 55 and 56. Then lecture 57 design of acceptance sampling for variables and 58 acceptance sampling in Minitab. So you can see that week 10 is totally devoted on statistical process control and week 11 is acceptance sampling, which is also a part of statistical process control. So now we would like to cover in this particular lecture need of QC approach, benefit of QC approach, and there are traditional 7 QC tools. Couple of them we have already discussed, but I would just like to have a quick revision, because usually any book if you refer, then it's a classical topic that what are the 7 QC tools. So let us see that problem solving and problem solver. And when I say how to know that there is a problem, diagnostic, analysis, interpretation, it is about problem solving. Now when you say solver, you may have self-negating or despairing type, you may discuss, and self-negating approach you may have, someone else fault type, it's not my fault, you will just try to get rid of that, then ostrich type, and you can have QC problem solving approach. So obviously we need the solver which are scientifically designed and can really help me to avoid the conflict, internal or external, and convince the people for the right cause of the problem. So QC tool basically is the 7 QC tool helps me to get hold on my situation problem in a scientific way and convince the people about the real cause of the problem. So what is a QC approach? So typically views problem as opportunity for improvement, very important. Many times in the life, personal or professional, we just try to avoid the problem, we just try to hide the problem, but QC approach says consider the problem as an opportunity. Then focus is on continuous improvement through PDCA, plan, do, check, act. We have seen this cycle also. Looks for quantification, then looks for trends, past data to support that what is happening and what can happen in the future. Analysis in group mode, so nobody can blame. You are taking the inputs from the people, you are doing brainstorming, so it's a group based approach. And implementation, and again look for opportunities for improvement. So it's a complete PDCA cycle. keep revising, keep checking, keep planning, doing, acting, and then you can reach to the Six Sigma level. So there are various approaches, as I mentioned, that it basically helps you to get hold on the situation and improve it continuously, and when you are involving the people, it also improves the moral participation of the employee. So simple and easy to use tools motivates the people to go by management by fact and data, not by whims and fancies, not by intuitions. Let us have black and white. So let us try to separate it and let us try to convince the people for the real cause of the problem. So what are the typical 7QC tools? So you can see here that CheckSheet is a very well known tool, histogram, then stratification, Pareto diagram, cause and effect, scatter diagram and control chart. So I will give you the brief idea of each of the tool, and control chart I will give you the brief, but as you have seen, we will discuss this particular topic in a greater detail, and we will see the design of control chart for variables as well as attributes. So with this say brief overview, let us try to study the tool quickly, because many of the tools you know or we have discussed previously. So CheckSheet is a very simple tool. Say you will find a CheckSheet hanging on the machine panel, and let us say it's a CheckSheet for cleaning, CheckSheet for maintenance, and then a person is only need to check it out. You will find, if you visit airport, then just backside of the door you will find the cleaning schedule and CheckSheet. Similar way, cleaning schedule is displayed in the form of CheckSheet in hospitals. So it's a very simple tool to see that where the process stand, what is the present progress, and what is to be done, what is left over. So this is the benefit of CheckSheet, which is a very simple tool to follow by even a very less knowledgeable person, say unqualified person, and you can also say put a tally here and count the total, that how many times this is being checked, how many times this is being cleaned. So missing ring to tally is 2, print quality so many 23, and then you will get an idea. So this is my CheckSheet. Now the second one is histogram. Basically it's a kind of bar chart and bar graph, and typically used to present the frequency data. So define the categories for the data, sort them out. We have seen this in detail, and this provides an easy way to evaluate the distribution of the data. So we have seen that whenever say you try to analyze your validity of your model, regression or other, your Minitab output will give you the histogram as well as normal probability plot. So first hand idea you can have how my data is distributed. So this is what is histogram all about, and just see this example that my machine is failing, and over a period of X week I want to see, suppose this is the maximum limit or upper specification, lower specification. Within this, the failure of machine, this is the number of time machine has failed in a particular week, how the distribution is. I can at least figure out that whether in a particular week or particular month or particular day, whatever may be the time window, something is really going worse or it is just a normal phenomenon. So the interpretations are 3 basically. How well the histogram is centered. So centering of the data provides information that whether my process is centered at mean or nominal value or not. What is the spread? So it gives me the idea about the variability of my data set, and shape, it may be skewed. So if my assumption about the normality is not valid, then my majority of the model, whether regression, my statistical analysis or my control chart, everything based on the normality assumption, and if it is not valid, then my analysis will lead to the wrong conclusions. There are certain limitations that you cannot do inferential statistics. Obviously you will just get a bird's eye view that what is happening, how my data is spreaded or skewed. This is the run chart, and you can say that, let us say this is the month January, February, March, April and so on, and this is the run chart for customer complaints. So these are basically the customer complaint. What does it tell? It's a simple representation that there are 4 customer complaints in January, there are 3, there are 6, there are 5, 5, 8, 2, 3 and again 3, and this is 4. So it's a very simple visual representation that helps me to understand that how my customer complaints are changing, whether a particular month here is really of importance or critical. For example, the maximum number of complaints you receive in June. Now you can investigate that whether my people were on leave or my sales representative, or if it's a case of restaurant waiters were different, or some other reasons were prevailing, or there was a heavy rush. So you can figure out that why the number of customer complaints were more. So it just gives you that how your data is placed with respect to a time window, and you can analyze with respect to say previous or succeeding data. So this is my run chart and displays the process performance over a period of time. You have another tool which you have used right from your schooling, that is the flow chart, and typically it helps me to map the process, define the important junctures of my process and also the decision points. So typically if you want to indicate the start and stop, then this is the symbol you use. If you want to say action, so some processing is going on or something is happening, then it's a box. Then diamond, it's about choice, decision making. Arrow, it connects the various symbols and shows the flow. So this is what is my flow chart, and you can just see the example flow chart. There is a department 1 and there is operation 1. So I have used this. There is inspection, something is happening, so box, decision point, no or yes, whether you have to go for rework or you will pass it, storage, operation, and then it will go to department 3. So this is a very simple understanding of my flow chart, and processing in department 2 can even be captured through a systematic flow chart, and that will give the people, workers, a very simple and easy way to understand that how the things are streamlined. Now Pareto chart, as we have learned that it follows the 80-20 rule, and a renowned economist Pareto gave this particular logic, and he realized that 80% of the wealth of the world is in the hand of 20% of the people, and only 20% is available for the 80%. So he came to a conclusion that there is no point in focusing on all the problems. If you can figure out vital few, then the 20% can really cause the 80% of the problem, and rest 80% are only responsible for the 20% of the problem. So this is what he has done, and typically it identifies the factors that have the greatest cumulative effect on the system, and I can represent my typical Pareto chart like this. So you have this data arranged in the descending order, and then you find the cumulative frequency, and then you try to see that at a particular 80% where it cuts. So 80% say it cuts at a particular point, and all the problems below this are really of importance because they contribute to 80%, and I will focus on these problems first. So this we had previously also seen with the example. The another is scattered plot, and we had seen in correlation analysis also that there is some scatteredness in the data, and you try to capture this or you try to find out a best fit line or correlation. So scattered plot basically says that how my data is distributed, how my data is scattered with respect to maybe variable x and variable y in this space, and can I fit some best fit line y is equal to mx plus a. So this shows the trends over a period of time. Suppose it's a productivity, and suppose x is the time and y is my productivity, then I can say that how my productivity is increasing with respect to time. So this is about the scattered plot. You can refer couple of examples. Cause and effect, we all know that this is the most important approach for conducting the initial brainstorming exercise and identifying all the possible causes that can lead to a particular effect. So it is also called Ishikawa diagram, fishbone diagram, and cause and effect diagram. So typically your cause and effect diagram enables the team to focus on content of the problem, find out the causes and symptoms, and allows the people to easily see the relationship. So just see this, there is a problem with the age flows in manufacturing process. There could be machine related problems like timing, stamping, molding. There could be operators, training, supervision, moral, material, specification, color of the material, base variation, and there could be problem with the methods. So you have the effect, you have the causes. Causes are further separated as the main causes, and within the main cause you have the branches which are your sub causes. So this is what I have just written here. Now coming to the last tool in my 7 QC list. So the 7th tool, which is the most important and widely used tool on which we will devote couple of lectures in detail, and that is the control chart. So all other tool can also help me to control my quality or get hold on my problem, but control chart, because they are statistically driven, it's really a scientific tool to achieve better control on my processes and take the corrective action at the right time. So it works with the upper limit, upper control limit, lower limit, and central line, and the moment you see that your point is going outside the control line, just I am giving you a brief, then there is an indication that something is going wrong and you may think about a corrective action. So there are different types of control charts for variables and attributes. For variables, X bar and R chart, or X bar and S chart, or sigma chart. For attributes, you have P chart, you have C chart, you have NP chart, you have U chart. So we will see how to construct the control chart, how to design them, and what is the purpose of each particular chart in the subsequent lectures. And typically it sets the lower control limit, upper control limit, lower control limit, and center line. This remains same for all the control charts irrespective of their nature for attribute or variable, and we can have the idea about the process control. So just see this, that this is my upper control limit. How to determine, we will see. Lower control limit, you can see that up to this there is a stable process. These are some of the spatial causes. You may say that there is something instability, but these are the common causes. So whenever you see that the randomness is within this particular limits, this is just because of chance cause, random, common, you cannot avoid it. Any process will have some variability. For example, if you measure your blood pressure in the morning, maybe you get fantastic reading 110 and 80, but if you measure it in the afternoon, it may be 120 and 80 or 85, and if you measure it in the evening when you are extremely tired, it may be little higher, 130 and 90. So it's okay, it is all well within the range and it is acceptable. So long these variations are well within these limits, they are acceptable. There are some special cases when if some typical trend prevails, then that is an indication of some abnormality, assignable cause, that we will see in detail later on. But just for the simplicity, we assume that if the point is falling outside the control limit, there is a concern and there could be an assignable cause prevailing. If it is all within the control limit, I need not to worry. So, there are benefits of control QC tools. It provides training in thinking. Remember, when you execute this, it triggers your thinking, how to think in a more scientific way, rigorous way, directional way, raise people's problem solving confidence. You stand with the data, you stand with the trend, you stand with the facts, and then you have better confidence in your results and recommendations, and you can also convince the other people and top management. Increase people ability to predict future events. So you are not only struggling with day-to-day life, but you can say that, okay, what will happen down the line? So you must have seen the insurance company, they are asking that are you a smoker? Do you have diabetes? Do you have blood pressure? Have you gone through some critical surgery? If yes, then you will find that they will raise their premium, because they have some standardized table available that if you have this problem and if you are a smoker, then what is the risk to your life, and then they can better predict the consequences that may occur in the future. So these are the couple of benefits of the 7QC tools, and there are various roles 7QC tools that it express verbal data diagrammatically, information visible, organize information intelligibly, and clarify overall picture and get more people involved. So progress check, determine which of the 7 basic QC tool would be most effective for each situation. I want to put you in a little bit thinking process. Let us say this is case 1, and it is like this. The value furniture company is having problems with customer orders. Within the last month, several orders were failed incorrectly, and 5 customers have complained that they never received that furniture. So as a manager of the company, you have decided to examine the customer order process to determine ways in which the process could be improved. So which of the 7QC tool would be most appropriate, and what kind of steps would you like to follow to address this problem? Let us see the case 2. You are a new quality engineer for a machine parts distribution, and management tells you that the factory has not produced the normal amount of parts during the last, say, past quarter. So they would like for you to determine whether there is a specific problem causing the decreased number of, say, over the past quarter production, or if the part making process needs to be, say, upgraded, updated or modified. You have to access to past production data for use in your analysis, and which quality control tool you would like to use to propose an amicable, reasonable, practical solution to the management. So think it, how the quality tools can help to improve the overall system's productivity. 2 variables X and Y are related. Variable X increases or decreases with Y. Which tool could be, or tools could be best used to graphically show this relationship? Which tools would be most appropriate for collecting data to study the symptoms of a problem? So just try to introspect, and that would help you to digest the concepts better. So these are the references you can definitely refer. And quality control tools, as I mentioned, provides a directional way to attack on your problem and convince the people for your recommendations. So thank you very much for your interest in learning 7QC tools. I hope this video would help you to appreciate the importance of these tools. We will do the detailed analysis and develop a greater understanding on various quality control charts in the subsequent lectures. Till that time, keep revising, be with me, enjoy.